All right, middle school math. What's up, y'all? It is March 18th. As many of you can see, it's a good day to wear red. Felt like in honor of the Patriots and Tom Brady, I should go ahead and wear the Tampa Bay gear. So, we're going to go over two lessons today from our Glencoe Math, McGraw-Hill, Course 3, Chapter 9, Lesson 1 and 2. This has to do with scatter plots and data analysis. So when we're looking at a scatter plot, what is a scatter plot? It shows the relationship between a data set with two variables graphed as ordered pairs. I just heard the word ordered pairs. Makes me think of an X, Y, and a graph. Oh wait, yep. I see some X, Y, and graph down here. We'll get to that in a minute. So the pattern that these two X and Y associations make, the pattern of the data points determines the association between the two sets of data. There are three different options when we're looking at data, the association. It could have a positive association, negative association, or no association. This is real simple. You guys you've seen this before. The way we read a book. Left to right, top to bottom. Down here, which way? If we were to roughly estimate, looking at this information, the data, which way it's going, looking left to right. If we were to drop a ball right here, this would be going upward, or generally upward from left to right, showing a positive association. It also then, if we were to read all this, which we're going to, because this is part of it, there are many questions in here. Looking at this one, just looking at a quick association, get out of there. Negative association. Now let's see what they're asking of us. Explain whether the scatter plot of the data shows a positive, negative, or no association. Well, we just did that. We just proved that has a positive because it's going upward from left to right. So from the origin, it's going upward. Positive association. Interpret the scatter plot. That means what do these numbers mean? This means for every mile driven, how much gas is being used. So the more miles that we drive, the more gas we use. Or more gas gets used the further that we drive, the further miles we drive. Continue on, and there are a few examples here. Looking at this real quick. Positive, negative, all over the place. No, it's not Jackson Pollock. This would be considered no association. You cannot form anything out of that. It's a scattered mess. No association. Second, this is tricky. Don't overthink this. Line of best fit. The word best fit. You are the one giving it the best fit. Boat sales at Dustin's Marina are given. We know that the amount of weeks and how many boats he's selling every week. Looking at our X and our Y. X would be how many weeks or time, and the number of boats that he sold as Y. So let's give this an X and a Y. Remember, ordered pairs get written as X, Y, where we go left to right, and then the Y goes up or down. So in the ordered pair of 1, 2, graphing that, over 1 from the origin, over 1 on the X, up 2 is a unit rate of 2, giving us an ordered pair of 1, 2. These are all graphed you can see over here. I'm going to choose another one at random. 6, 10. Over 6, up 10. Line of best fit. With all those graphed, they are estimated that the best fit of a line is right about here. Construct a scatter plot using the data. We did that. This is all made for us. We plotted every set. Then draw and assess a line that seems to best represent the data. That is our line of best fit. Graph each of the data points and then draw the line that fits the data. Done. That is all we are doing. It is not asking us to interpret this data at the moment. If we were, we could roughly interpret how many boats Dustin's Marina would roughly sell over X amount of weeks, and there's a formula to do that. They're not asking us that. Look at the graph, interpret the data. What are they asking of you?